So page 15, this is definitely study sheet material. So there are four ways, right? So to represent data graphically, there are four ways to do that. I would strongly suggest before you even start attempting to come up with a graphic representation, just find the MCTs, that's your mean, median, mode, and standard deviation as well as range. Right? So you have your mean, your median, your mode, your standard deviation. Those, I would say, and even range, it doesn't hurt to have your range. And how do you get this? You use one variable stats. So it's a little reminder, because guess what? Once you get to the exam, you might forget how to get there, or what is it that I had to do to get this. And then we have line plots. We've already covered that. So these are the four that you must know how to do. Okay. Line plot, I think there's not much to it. I'm just going to do one of these. Okay. And we've already covered that, so I will move on to the next one. The frequency table or chart, this one right here, I'm going to circle that one because this is a requirement in order to do 3 and 4. You cannot do 3 and 4 unless you have a frequency table. Okay. So a frequency table, I'm going to make an arrow to go off of it just for your study sheet. It should always have 3 columns like this. And we usually have interval, we have tally, and we have frequency. Hence the word frequency table. A histogram is similar to a bar graph. So a histogram is where we simply have bars that are connected. Okay, that's a histogram. And a frequency polygon, it connects dots with straight lines. And what I will do here is this. I will tell you that the best way to... You've awakened the beast. The best way to come up with a frequency polygon is to make a histogram, and then all you need to do is make a dot halfway, like if you consider the width of the bar, you make a dot right in the center, and then we connect those with straight lines. And so it's almost like you're doing 2 graphs in one. So the frequency polygon is the straight line graph, it's the line graph, and the histogram is the bar. Okay. Line plot, I think I've just given you a little reminder. This is how you, this is kind of the steps that I would take to come up with a line plot. Notice that range is not an MCT. Some students label the range on the line plot. That's not an MCT. Like, you can't label the range. The range is the difference between the highest and the lowest. Okay. Let's talk about the frequency table, because that's going to be the key to everything else. Did you have mini Olympics? You had them? Yeah? You're not the grade that missed out on it. That's, I think, grade 12s you missed out on mini Olympics because of COVID. So frequency table, here it is. This is a little messy. Like, there's a lot here. I think you can, after a while, you're just gonna know what to do. But if you need to review, okay. So we're gonna have 3 columns with these headings there. I would always suggest you sort your data no matter what. Okay. Determine the number of intervals. I'm going to tell you straight up front, I'm going to tell you how many intervals there will be on a test or quiz. But normally you can choose, like we can choose between 5 to 12. That's what we normally do. But don't worry about that one too much. The number of intervals can be chosen. On an assessment, you'll be given the number of intervals to be used. So you don't have to, it's not going to be a guess. And the reason being is it's a nightmare to mark. If you choose 5 and somebody else chooses 6 and 7, then I have to check all those numbers. And it's just, it's not necessary. Calculate the interval width. Right, this is the range divided by the number of intervals or rows. Okay, that's how you figure out the width of the interval. You can round this number, absolutely. We don't want decimals if at all, if we can help it. Start the interval column using the interval width. Use a low enough number, okay? Use a low enough number to include the lowest value of the set, and then just move up. And this is this gets a different color here. It doesn't happen very often, but when it does happen, if a value that you're trying to put into the chart falls between two intervals, you always place it in the lowest. Okay? So let's say you have your width is 60 to 65, and then it goes 65 to 70. Okay, so that's just zooming in. If you have 65 as one of the values you're trying to put into this table, you're going to pick the lowest, okay? It's going to go into the lowest bracket, not the highest, okay? So that's something to remember. All right. Here's a frequency table that I've already made for you. It's showing the heights of planted trees. So you've got trees between 100 and 125 centimeters. There are 3 of them. So tally means we're going to actually put marks down as we count. So once you're done, you take the 3, you put number 3 in the frequency column. How many are in here, folks? Can you see this crossing here? That is 5. Okay, you go 1, 2, 3, 4. Once you do 5, we cross it out like that. So this is 5 plus 3. There are 8 trees that are in this category, in this interval. And then another 3 here. And then we have 12 trees that are between 175 and 200 centimeters. How many do we have here in total? We've got 26. So where should I do this? N is equal to 26. If you add all these up, you get 26. So 26 trees are considered in this table. Okay? Listen carefully to this part. In order to find the mean and standard deviation, all those things, you need to figure out the midpoints. That's extremely important when it's a table like this, because we don't have all individual data points. It's already arranged in a table. So how do you find the midpoints? We go, I'm going to give you the formula here. Write down this formula here. Midpoint, right? It's high plus low in brackets divided by 2. High plus low divided by 2. How does that work? This is an interval, so this is the low, this is the high. Okay, so you just go 125 plus 100, and you divide it by 2. You're literally going to find the middle between those two upper and lower limits. And what do you get there? You should get 112.5. This is also in centimeters, by the way. And if you do that, the same thing here, 125 plus 150 divided by 2, you get 137.5. So it should be a number that you can clearly recognize is in between these two. You keep going. This is 162.5, which you can tell is halfway between 175 plus 200 divided by 2. Make sure you do the brackets. Brackets mean do the top first. If you don't do the top first, you're not going to get the right answer. That's 187.5. let's pause a little bit, like we'll leave it as is. We'll move on to making the graph. So this is my frequency polygon, frequency table, sorry. This midpoint, I just added. Normally, this is all you're gonna have. Let me highlight that part. This part right here, grab a highlighter or something. This is what we consider the frequency table. Okay, that part right there is the frequency table. Listen carefully to this part. The midpoints, you're gonna add this column. You're gonna have to add the midpoints later on. Okay, this is just for later. Let's keep going. Use the frequency table to create a histogram or frequency polygon. Histogram is our third. This is our third option to graphically represent, and this is our fourth option. So basically, how do you do that? Interval is placed on the x-axis. Frequency is on the y-axis every time. And this is something worth giving it a different color. If you're not starting at 0, use a zipper. So we're gonna use something like this, okay? A zipper along the x-axis. So let's use that table to make this happen. Here you have frequency. And frequency for us is number of trees. In this case, like how often is a tree between a certain height? That goes there. What is our highest number for frequency, folks? Let's go to that table real quick. You see that? The highest number we have is what, 12? So if we go up to 15, we're doing fine, correct? So this will be 5, 10, and then we'll just leave the rest as is. We can put 0 there, it doesn't hurt. And what about our x-axis? X-axis is determined by which column again? It's the interval, this one right here, the interval. Do we start at 0 in this interval? Sorry, my camera work is less than. Where do we start? We start at 100, right? And we end up at 200. So you kind of have to keep that in mind. So we're going to do the zipper thing in this particular case, because I don't want to start right from 0 and then have a consistent scale. So this will be 100 right here. And what's the next thing? Like it goes from 100 to what? Look at your interval. It goes from 100 to 125, right? Use that. Use that. That's going to be the easiest way to do this. And then we go from 125 to what? 150. And then we go to 175. And then we go to 200. And we can stop there, right? I designed this that it works out just perfectly, right? And so what's the problem with the x-axis right now? You're going 100 and then all of a sudden you're going up by 25s, right? You cannot have that. So introduce the zipper right here. Okay, that fixes our problem. Only in stats can you do that, right? Don't do that in quadratics or any other unit. So let's do the bars first. You might need a ruler for this unit. So from 100 to 125 in our table, how many trees do we have in there? 3, right? So we go up to 3 and we make a line, that's our cutoff, and then create a bar like that. Okay, and I always like to put down how many that bar represents. It represents 3. The next one is 8. Between 125 and 150, we've got 8 trees in there, which is right here. I make that line, and it should be touching, right, the other bar right here. So that's 8 trees. And next we have 3 again. So we're down to 3, and that's between 150 to 175 centimeters. and the last one is 12, correct? That will go up to here, make your line. And this will depend very much on the scale you're using, right? So you've got 12 there. That is, what do we call this? This is our histogram, right? Histogram. And I'm going to, right over top of this, do my frequency polygon. It's much easier doing it that way. I'm going to use a red pen for this part. So frequency polygon, you're kind of figuring out between 100 and 125. The middle is right there. Between 125 and 150, the middle is right there. So you're just finding the midpoints, essentially, without having to do the math in this case. And you connect them from dot to dot, okay? But right now, you would not get full marks yet. You have to make contact with the x-axis at one point. So just take your ruler and make contact with the x-axis, and then you're fine. Okay, so technically you should add here. And there's one more thing that I just noticed that is missing in this graph. Anybody? Half a mark deduction right now. What is it? Arrow, yeah. And another thing. There's no equation, but we need to label the x-axis, right? Yeah. It's very annoying, but I know. So what do we have here? Hi.
Sorry about that. You guys don't have a data cabinet in this class, or do you? A black thing hanging on the wall?
No.
Work stuff?
No. No problem. What do I put as my? You can go height of the trees in centimeters. That's what this represents in this case. So we're comparing the height of the trees and the amount of trees that follow each category. So you've got, so again, just so you understand, this is the histogram, okay? And the lines that I've connected, that is the frequency polygon. I have them both on the same grid. It's just way easier. I actually tell my students, even if I only ask you for the frequency polygon, do both. Because it's just so much easier to do than having to calculate the midpoints. Because these numbers, I take them straight from my table. Okay. All right. This is the new part. Determine the mean and the standard deviation of this data set. Mean and standard deviation. So I want to make a note here. Note, we are not given the raw data points. What does this mean? You're not given the raw data points. Do you have like the measurements of every single tree individually, like a table with all those measurements? We don't have that raw data. We don't. We just have the table. Somebody created that table for us. So what you must do is this. Therefore, calculate midpoints. That is very important. I'm going to highlight that. And so this is for your study sheet perhaps. So if you have these three, okay, interval, one more time, interval, tally, and frequency, you must add, I will do this with a red pen, okay? You must add the midpoints, okay? So we're gonna do that separately. And guess what? What do we do after that? We put this into L1. this one that we've created that we're going to calculate for every single interval. And we put the frequency, the amount of items that we're considering, into L2. So L1, L2. Okay. So let's go ahead and do that. Grab your calculator. And we're going to go to Stat, Edit, clear whatever is in there. And let's go to our table real quick. We've already done the work of figuring out the midpoint. So I will do this on here as well. I will say that I'm putting this into L1 and I'm putting the trees into L2. Okay. And let's enter that into our calculator. We go 112.5, 137.5. Got it? And then the frequency goes into L2. And what do you think we're going to do with one variable stats in this case? Because you've got two columns, right? One variable stats, L1, comma, L2. Oh, you can't see that, sorry. So from here, we're going to go to one variable stats, L1 and L2, and then we're going to come up with our mean and standard deviation. So stat, edit, one variable stats, L1, L2, hit enter, and there it is. So the average height of a tree in this case is that tall, okay? And my standard deviation is 27.67 centimeters. And what does n represent here? You see that n is 26, okay? 26 trees. If you forget, okay, listen up quickly here. If you forget to put in the L2 and you hit enter, what's n in this case? It's just 4 because it thinks that you're only considering, it literally thinks that you're only considering these 4 trees right here that measure the following dimensions, right? So you need to type in L2 to consider. The calculator knows, oh, okay, you mean that there's 3 trees that have an average height of 112. There's 8 trees that have an average height of 137.5, okay? What's the time? Okay, it's time to practice this real quick. I want you to, we're going to skip 17 for now, okay? I need you to practice this. I want you to read this page on 18. And I want you to find the mean and standard deviation as well as the range for the salaries in this table. Okay? And then tell me how many employees work for this company. So in a sense, I want you to find this, the range, and I want you to find n, okay, for that table. Question, is this a frequency table? No. There's no columns, right, with headings in there. This is raw data. This is raw salaries that we've collected. So please find that. Once you're done that, you go to the next example here. There's a table that shows the salaries of company B. What does this look like? Does this look like a frequency table? Yes, but you might think, Mr. Dirksen, you told us 3 columns, right? The tally column is not here. That's okay, right? So what we're gonna have to do here is what? What's the first thing you have to do when there's a table like this? Midpoints, yeah. So actually I'm gonna start that off for you. I wouldn't close it just yet. So just call this midpoints. you're going to figure them out. Right? You're going to do the math and figure out these numbers. Okay? Every row should have its midpoint. And what are you going to do to find the mean, standard deviation, everything for this particular example? You're going to put the midpoints into L1, and the number of employees are our frequency, right? Like how often data falls between this interval. That's going to go into L2. And so I also want you to find the mean, the standard deviation, the range, and the number of employees for that second example. So we're mixing it up here. One has a frequency table, one does not. So go ahead and find all of those values. I'll give you a little bit of time. And then we'll continue time to do that one big graph there. At least fill out the frequency table. If you don't mind grabbing a highlighter, just when it's a frequency table that you're dealing with, then this is the note that goes with it, which explains what we're doing, right? We're finding the midpoints. We put the midpoints into L1, the frequency into L2. And you should see something like that when you're about to find the mean and the standard deviation. So please don't forget that when there's a table with categories where you see they have different headings. It's not just a bunch of numbers that are just all listed. If you have different headings like that, you need to make sure it's like, oh, I need my midpoints, and that goes into L1. Because you can't enter both of these into your L1, right? It doesn't work. Okay. So for the first one, I don't know what you got there, but I'm just gonna, if you did that right, you get 3,835.25. The standard deviation is 914.22. The range, when you arrange this, you grab your lowest and your highest, you subtract it, so you get 6,500 is the highest salary minus 2,750. So the range is 3,750. Okay, N represents 16. What in this case employees, right? That's what that represents. If you put down salaries, that's fine. 16 salaries, 16 employees, but it did ask for. I could sometimes ask you, like, what is N in this case? What's the significance of N? N in this case represents the number of employees this company is considering, right? When we're considering the salaries. Next, for this one, the midpoints, if you did that right, you get 2250. And make sure this number is actually in between the two limits, right? Then you know you're doing things right. 2750, this is 3250, this is 3750, and 4225. Okay. Sorry, no, 4250. That's what I meant to say. You put that into L1, this into L2, and then it's one variable stats, right? One variable stats, L1, comma L2. I think it's a good habit to make sure you understand that. The mean is 3210. The standard deviation is 467.33. The range you just go off of this basically. Okay, the highest is 4250. 4,500, and the lowest is 2,000. So it's 2,500. I think you get 2,500 regardless, right? No. Did you subtract these two here? If you subtracted these two as your min and max, then it's 2,000, right? I don't think it's a fair question to ask for this, so let's just, whatever you got, that's fine. N would be all of these values. N is equal to 25. Right? I always make a note here on my tables, like just making sure that's 25. But 25 is employees, right? In this case, that's the significance of it. And how do the salaries in both companies compare? Using your mean and your standard deviation. So you can say that salaries in company, I'm going to talk about company A. Company A what can we say? Tend to be higher or lower when we look at the average? Higher, right? Like look at the average. You can say salaries tend to be higher overall. Greater mean. I'll just make a note. This is how I know has a greater mean. Okay. Let me bring that up because some of you are in the back there trying to look over somebody's shoulder there. Greater mean. That's how I know that. The salaries are inconsistent compared to company B because the standard deviation is greater. In other words, i.e., salaries in company A, are spread out and when things are spread out, there could be that there's like a few people that make a lot of money, like their salary is significantly higher, and that's like dragging up your average, right? So are spread out, and the higher average may be due to outliers. That is honestly above and beyond. I think if you just had the first couple of sentences there, you're fine. Okay. And time is always running out. So I'm gonna leave page 17 for tomorrow. But here's what I always have a plan B. Okay. Come with me to page 19. So on page 19, I want you to find the mean and standard deviation of class A and class B. Okay? Question, is this a frequency table? I'm afraid to tell you no. Okay? It's not a frequency table. How so? Because this is just saying class, it's almost like putting two questions together. This is class A. Remember the battery question? Right? This is class A. And this is class B, but there's no range of scores, right? There's no like students that scored between 50 and 75, there are 4 of them, or we don't have that scenario here. So no need to do that, but I want you to find it for class A and class B, and then, you ready for this? You're gonna scan this QR code. I'm going with the times, guys. I'm not that far behind. And this is another skill that I need you to know is how to calculate the standard deviation by hand. Like actually doing it by hand. It's actually quite tedious. That's why I'm not using too many numbers. And I'll show you how to do it here. So that's going to be your homework. And I'm not done yet because that would be, I think I need you to do a little bit more. So page 19, let's write this down, 19. Page 20, I just want you to do up to B, up to B. You don't have to make the graph yet. Sorry, you can't see that again. Sorry, I'm way off today. What's going on there? No graph, that's what I'm gonna say there. Leave the graph for me to do, teach you how to do that properly. And then one more question on page 21. I want you to do those ones as well. So page 19, standard deviation by hand. Okay, page 20 up to part B, and then page 21, all of it. Okay. Please do this, because if you have a good sense of what we're doing here, how do I explain it, right? What does the standard deviation tell us in different scenarios? It's very important to know how to do it. There are frequency tables. Is this a frequency table here? This one is. So look at how you've got the width, right, interval, and you've got how many. And by the way, it says frequency, then it's a dead giveaway. It's a frequency table. So I just want you to find the mean, standard deviation, all of that. And I still have some time, so just listen up here. Page 21, this one right here, is very similar to the players. There were different players that we talked about on previous pages. I didn't talk about it today, but you're going to find the mean and standard deviation for each group and talk about, right, which one has the lowest mean pulse rate. Obviously, the group that has the lowest mean. And which one is most consistent. Which one is going to be the most consistent? The one group that has the lowest standard deviation. Okay, so we're going to investigate that. All right.